Okay. So we're doing a recording here. It's Monday, May 31st, sorry, peer review group. And this is the 2003 multiple choice calculator, pale green packet. Look at number 86 again. It's the volume question, section 8.3. And here the base of the solid is the region, the first quadrant bound by the y-axis, the graph of the inverse tan of x, the horizontal line y equals 3, and the vertical line x equals 1. So a lot of information we have to process here. So you really need to draw this to visualize it. And then for the solve, each cross-section perpendicular to the x-axis is a square. Okay, so again, they're feeding you just a crazy amount of information. So what I would do is I'd draw your coordinate plane. Okay, easy enough. Then I would draw y equals 3. Actually, let me do that. Okay, y equals 3. Here you go. X equals 1. Here you go. Now, inverse tan, remember, do you have a calculator? And actually, I'm not sure how inverse tan looks off the top of my head. I should, but let's cheat and be in radian mode. Okay, so it kind of looks like this. It's passing through the origin. And this one kind of like that. And again, it's bounded by y equals 3, x equals 1, and has to be in the first quadrant and the y-axis. So the region that we're looking at is actually going to be this region right here. Okay. That's the region we're interested in. And your cross sections are squares. They're perpendicular to the x-axis, so it kind of looks like this. So the volume is going to be, you integrate from A to B. So we'll call this A here and B here. Of your area in terms of x times dx. So we're actually going from 0 to 1, because we're bounded from x equals 0 to x equals 1. The area is going to be s squared. The tricky part is figuring out s in terms of x. So that's where you really want to label the coordinates. So that could be like x comma 3. And that will be like x comma the inverse tan of x, because that's y is being determined by that expression, right? Inverse tan of x. So it's going to be the y upper minus the y lower, or 3 minus the inverse tan of x. Okay, easy enough. So now you square that. Because the side squared, right? Dx. And you would be kind of insane to do this by hand. I would totally use your calculator and just work it out. So go ahead and try this on your own. Punch it in the calculator. Just make sure you're comfortable putting this all in the calculator. And then go ahead and tell me what choice you get in the chat. Remember, we'll go from 0 to 1. And parentheses 3 minus inverse tan of x. Square that sucker, dx. Okay, and tell what you get. You put in the chat. So, I didn't get that answer. It's actually not one of the choices. Make sure you're in radian mode, by the way. You might be in degree mode. I'm actually curious if you were in degree mode.
I was in radian.
No, you're in radian mode. You may have messed up this, or do you square everything?
I'll check again, but maybe I messed up the parentheses.
No. Interesting. I'm trying all these different errors you can make. Maybe discover an error that I did not think was possible.
Forgot the negative tangent. There we go.
Got it. Yeah, the answer should be B. Yeah, it's B. Good. Yeah, it's B. Okay. So, okay. Let's see if we can locate another similar kind of problem. Let's look at 2008. Let me look at for response then. Let's go for response without calculator. Actually, let's turn back the clock here. Actually, I'm kind of curious the May 24th PDF. Is that, no, I don't see that. Let's see. Yeah, let's look at 2003. Here we go. Great. Here's yet another one. And it's calculator. So this is 2003. Okay. So you have root x and e to negative 3x. So hopefully you know which one's root x, but you can always graph your calculator. This was a calculator question. So this is going to be y equals root x. This right here is going to be y equals e to negative 3x. Okay. And vertical line x equals 1. Okay.
We can use calculator, right?
It's calculator, yeah. You have to find the area of the region. So area, remember, is going to be from A to B of f of x minus g of x, where f of x is greater than or equal to g of x in your interval from A to B. Pretty obvious that root x is higher than e to negative 3x. You will need to find this point of intersection, however. So I know the upper limit is going to be 1. You got to figure out the lower limit. And of course, you have root x minus e negative 3x dx. So for part A, as we will need to do, you do need to find the point of intersection. And I would strongly, strongly recommend that you immediately let y1 be one of these functions and y2 be the other. So actually, what you could do is call this y1 and call it y2. And remember, to call it up, you hit alpha trace when you're in the home screen. But you will need to figure this out, and you probably want to be a little bit accurate. You don't want to just round it too soon. maybe do a few decimal places, or you could store it. That's another thing you could do as well. So go ahead and work that out and then type in what you think the answer is. Okay, I do see one answer. I'm going to work out myself, see if it's the same thing. Again, y will be one of the functions, so root x. I'll do e to negative 3x for the other. Now I got to graph them to see where they touch. Okay. So once you find where they touch, when you hit second trace, so to find the point of intersection, you have to do second trace and select the intersect feature. It's going to give you the point of intersection for the two curves. I would immediately hit clear. And once you do find it, hit X in the home screen. It'll give you, it was 0.238734. You could store that as a letter. Stores right above the on button. And you could like alpha any letter you want. So let's say I store as alpha A. So I'm storing. That way it's just more accurate. So I'll put A down here. So now I integrate in the home screen. So alpha window, F and int, alpha A, 1 is my upper limit, alpha trace, y1 minus alpha trace, y2, dx. I get 0.443. So Ian, I believe you got that. Nice work. Yep, fantastic. If you have 0.442, if you truncate, that would still been fine if you didn't round up to the third decimal place. But it should be 0.443 or 0.442. Either of those would be accepted. Now, what if I was not terribly accurate with my lower limit? My lower limit was 0.2387. What if you put like 0.239? I'm just curious. What if I did that? I think it would still be okay. Yeah, you'd still be okay. What if I did 0.238 for my lower limit? Would still be okay. What if I round to 2 decimal places? So I did 0.24. Okay, we're still okay. So, all right. What if you did like 0.2, which would be lame? Yeah, then you're gonna be off. You get 0.441. So, yeah, just better safe than sorry, Okay, so now we have you guys. Now we're gonna talk about B and C, and then I'll find another volume problem for you guys to kind of work through. And that's, I think we'll do an Albert IO, but let's look at B and C. Now we're revolving this around the line y equals 1. Okay, so we're doing a revolution, right? Y equals 1 is right here. This is totally a washer method because if you look at my axis of rotation, look at my region, it's not flush with the axis of rotation. So there's going to be a gap or a void. So my center is going to be on y equals 1, right? Because I'm revolving around it. The inner rim is going to be from y1 here, or y1 was this, and y2 is going to be the outer rim.
A quick question.
Yeah, go ahead.
So is this like a double washer?
No, there's no such thing as double washer. What do you mean by double washer?
Oh, well, I guess you don't need to worry about the axis, the x-axis, or like subtract from that.
Yeah, no, that'd be, well, that's kind of mind bending. No, don't worry about that. So the bottom line is the volume of a washer will be this. You're going to integrate from A to B. Oh, there's a pi outside as well, because it is a constant. It's going to be the outer radius squared minus the inner radius squared dx. Why is that? Because when you have a washer, you have an outer radius, you have an inner radius. So the area is just going to be the difference in those two circular regions, right? The outer circle area minus the inner circle, right? So that's what the pi gets pulled out, and you have RO squared minus RI squared. The thickness of each washer, which I don't have my office here, if I don't have I can go to the garage, I'm sure I can find a washer, but it's going to be super thin, and that's determined by delta x. And you're going from A to B, where A is right here, which I already stored as A in my calculator as 0.238 something, and B, of course, is 1. So I'm going to be integrating pi 0.238 or 9, whatever, to 1. Now, how do I get the outer and inner radius squared? How do I get those actual values? What should have values? How do I get those expressions? This is why labeling is so important. I'm going to call this x comma 3. Sorry, x comma 1, my bad. So I don't know the x value. I know it's somewhere between 0.23 and 1, but I do know the y value is 1. Here, it's going to have the same x value as the center. However, excuse me, the y coordinate is determined by root x, because y equals root x is that equation for that curve. And then here, that's going to be x comma e negative 3x. Okay. So my outer radius is simply the distance from the y coordinate of the center to the y coordinate here. The y coordinate here. So it's going to be 1 minus e negative 3x. The inner radius is going to be 1 minus root x. So now if you had reversed, if you said e negative 3x minus 1 and root x minus 1, it wouldn't matter because you're squaring anyway, but it's just going to kind of be proper, high minus low. And sometimes your axis rotation could be down here, right? Where then this is the outer radius and this is the inner radius, so then you'd have something like this, and things would just get kind of reversed. That's what just helps the label and kind of like take the difference in the y coordinates. That's what I recommend you do. So 1 minus e negative 3x squared, and 1 minus root x, and that's going to be squared. Or really, it's 1 minus y1. Sorry, that's y2. And 1 minus y1. So this is the fun part. Let's punch this in our calculator. So alpha A. So go and try and tell me what you get. Go and punch it in. Okay. And going, tell what you guys got. Yeah, 1.424 works. So now we got 0.4531, but remember we got multiplied by pi. Don't forget to multiply by pi. Evelyn, you're off by a little bit at 1.52, so maybe you meant to put 1.42. But yeah, 1.424 or 1.423. And I would actually go with a decimal approximation. I mean, you could say divide out the pi. And you could say 0.453 pi. That could work also. So yeah, you have some options. But yeah, that's what's going on there for that one. So okay, good. So now let's move on to part C, and then I'm gonna have you guys try some. So this is kind of addressing volume, because I know that was kind of rushed for deep here, and I didn't really talk about the other group. So I feel this is an important thing to talk about, because I want to make sure you can nail these. You see them. The region R is the base of the solid. For the solid of each cross-section perpendicular to the x-axis, the rectangle's height is 5 times the length of the base in the region. Okay. So this is the length of the base right there, and the height is 5 times, so it's a really tall rectangle. So I'll call this L, and I'll call this 5L. So the area of my rectangle is easy. That's just 5L squared, right? L is the challenge, and then in terms of x. So that's just the difference in the y coordinates. That's just going to be y1 minus y2. Remember, this is y1, that's y2. And again, we're going from a to, from 0.238 to 1. So I integrate it, I'm going from 0.23 or 0.239, whatever, 1. And it's going to be 5 times y1 minus y2 squared dx. Because y1 minus y2 is the length of this, and then of course the other one's 5L. And if we deduce the area of the rectangle is 5L squared, L being y1 minus y2. So that's what you type in. I trust you guys are plugged in just fine these items, so I'm not too worried about now you guys plugging stuff into the calculator. But the setup is what I cared about. So 5 parentheses, even with the 5 to the left of the integral too, that's also fine, you know. Minus alpha trace y2 squared dx. You should get 1.554. And we'll look at the scoring as well, so you understand how the scoring will shake out. Excuse me. Okay. Any questions about that one? All right, so let's look at the scoring.
So is that, wait, so what do you, it says find the volume, but I feel like you found area.
No, I found volume because this is the area right here, and that's the thickness of each rectangle. So you're doing these rectangle slices. Delta x is the thickness of all those slices. That's the x part. Remember, I'm integrating the area, right? When you integrate area, you're incorporating another x, which is going to get you volume.
So like, what does the figure actually look like?
It's kind of weird. Let me actually go to calculus of motion. I'll find something that's similar. I know they're always kind of funky, right? Calculus of motion. Great question. Here we go. Let's do volumes on a base. y-axis. Like say, for example, well, I don't really have the best demonstration for you, but yes, you have these triangles, and the combination of triangles forms some funky solids. So I guess in our case,
It's just squares doing that.
yeah, it's a bunch of rectangles that kind of stick out of the page. And you have another rectangle that kind of does that. It winds up forming some sort of solid as a result when you stack all those rectangles of various sizes.
Okay.
If we look at the scoring, so 1 point for, or actually just 1 point in general for having, because all the limits of integration are all the same. So that's kind of overall. And then for getting set up the integral for the area and getting the right area was worth 1 point. For the volume, 2 points for the actual integral set, 1 point for the answer. And then for here, for getting the length, for the integral, I guess that's worth 2 points, 1 point for the answer. So that's how they break that up. Okay, so let's go to Albert IO, see if that's worth our while. No, I'll just try to find another question. Let's see, from old AP exams. We'll start with volume of cross sections, and we'll do revolution. Okay, that's a fun one. So what you're going to want to do here is get x in terms of y. And graphically, it's going to look kind of like this. When y is 1, x is 2. When y is 4, x is 4. Hold on, let me make sure I'm doing this right. So it's not sideways parabola, I lied. And y equals 1. But your cross sections are perpendicular to the x-axis. So let me redraw that. This is actually a really crappy drawing. Okay. Your heights are twice the length of the base. So that's L. That's 2L. So your area is that. But be very careful here, because you got to now do this X in terms of Y. So that's 0, comma Y. And when you isolate X here, it's 2 root Y. So go and figure out the volume for me. Remember, you're integrating this as X in terms of Y, not the other way around.
Mr. Omashny,
You go.
is the length just like 2 root Y?
Yep, exactly.
Okay.
And your limits of integration are going to be from 0 to 1.
Okay, thank you.
Your area is going to be 2L squared. So you put a 2 on the outside and square the length there and dy. Now I guess you get the answer. So I'll work it out. Make sure you guys get the same thing. 0 to 1. It'll be, we'll just say 4y or 4x. Actually, hold on a sec. Didn't get any of the answers there. That's weird. Two root y. That's the length. So you got to multiply by 4. Huh. I don't get any other answers. Let me look at the solution. right. Okay. Where it is. It's odd. Yeah. I didn't get in there. What do I did wrong? Did you guys get 16?
Yes.
I got 4.
Yeah, I got 4.
I got 4 too.
Yeah, I think they missed me an error because I don't. But the solution, it's hard to dispute it though. So hold on, try to understand. 2x base of each rectangle is 2x. Would it just be x? Yeah, I think they goofed. I don't think they meant to say 2x at the base of each rectangle. It's just, yeah, it should be 4. I'm curious how they got 2x at the base of each rectangle, which doesn't make any. Yeah, it doesn't make any sense to me. I think they kind of goofed there. Anyway. Okay. Let's try another one, but different shape. Okay. Have fun with this one. You may want to isolate y first, just so you know. And it's bounded by that curve, so it's interesting. So it's going to be plus or minus root 8 minus 2x squared. So you have to consider this and this part. And it looks like there is a restricted domain. It's kind of like knowing your conic sections or ellipses. hopefully you could see that your integration from 0 to 2. That's when enclosure happens. A-form triangles, isosceles triangles with a leg in the base. So it's kind of like that. So that's a side, that's a side. Area of a triangle, you should know, is 1/2 times base times height, or 1/2 s squared. Gotta get s in terms of x. Let me know if you guys get an answer.
To find s, you would have to, it would be the positive side of the ellipse minus
Yep.
the negative side. Okay, thank you.
So it's going to be,
Oh,
so you could call this
gosh.
x comma root 8 minus 2x squared. And this would be x comma, excuse me, negative root 8 minus 2x squared. So then it would be twice that. And of course, area is 1/2 s squared. So I could put 1/2 on the outside and square that sucker.
Why are you only integrating from 0 to 2?
Because it's bounded that way. So remember, this is what we got as our equation here.
Hmm.
Oh, wait one sec. No, you're right. I'm wrong. I'm integrating, my limits are wrong. It's from -2 to 2. Is that what you're getting in?
Yeah.
Yeah, it's from -2 to 2. My bad. I drew this actually somewhat incorrectly. So when you isolate y, you'll see that you're, and of course, graphing your calc. My guess this might be a calculator question, but you're bounded by negative 2 to 2 for x, because -2 makes y 0 and -2 also makes y 0. So yeah, actually, my bad. Should have been kind of like this. Yeah, from -2 to 2. Okay. Now I'm going to work it out. See if it's the same thing. That's going to be 2 parentheses 2 root 8 minus 2x squared. Times 0.5. 128 divided by 3.
Nope.
Yeah, you should get C as your answer for that one.
Yeah, I just.
Yeah, the answer should be 42.667 if you integrate it correctly. Yep. The answer is C for that one. So yeah, kind of wild one. but I think of being that concept of death, at least for cross sections. We'll see a revolution, and then we'll the second half we'll do kind of a more general review. See a washer method. So that one, there we go. What you guys do? Okay. So hopefully you see a graphic what's happening. Y equals x squared looks like this. Good. Y equals x cubed looks like this. Actually, I think it's a little bit smaller than initially. So it's kind of like that. And it's rotate, and it's the intersect at 1, 1. You're taking this region here, rotate it along y equals 2. So your outer radius, that's x comma 2, x comma x cubed, no, x squared. And the outer rim is x comma x cubed. So your outer radius is 2 minus x cubed. Your inner radius is 2 minus x squared. Okay. So integrating from 0 to 1. Yeah, pi on the outside. And 2 minus x cubed cubed minus 2 minus x squared squared dx. Lately now in the AP exam, they just find through doing the setup. I highly doubt they want you to do this by hand because it would take too long. So that would be the correct setup. And then punch in the calculator to see if you got it right. I'll actually do it right now. So 0 to 1. 2 minus x cubed squared. Yikes. I can't believe I said cubed. Wow. Yikes. Okay. So I get 0.276. So I convert that to a fraction. Ooh, I did get the fraction, 29 over 105. So yeah, you should get this choice. So hopefully we're okay at that one. So what I'll probably do is, you guys have access to this stuff, but maybe what I'll do is maybe I'll create a new cohort with those who are doing the AP exam, and then I'll just assign some problems. I think that might be good, and that way I can kind of see how you guys are doing. And I'll even do a mock AP exam this way as well. So I think that's what I'll wind up doing. I'll create a new group, call it, June 9th AP exam, whatever. Okay, cool. Well, we'll go about for another like 40, 50 minutes or so. We'll probably end about 1:45 till 2. So let's now go to we'll look at some free response questions. That might be a good idea. Non-calc. And actually, let's do an old example to see what you haven't done before. Look at 2010. No, no volume. I think we're tapped out of volume. Let's do 5. That's a good FTC style problem. It's always kind of nice to review. And then I would like to do one of the other calculator problems, which involves integrals net change. But yeah, these are like oldies but goodies. Let's look at number 5. And I'll actually pause the recording so I don't take up too much space here. Okay, so we're looking at number 6 from the 2010 exams as non-calc. We have to write an equation for a line tangent to the graph of y equals fx at x equals 1. So remember, the equation of the line is this. All right. And we're good. Well, first of all, when you plug 1 into the equation, we know we have 2. So y minus 2 equals, of course, x minus 1. To get the slope, you just plug in 1 and 2 into this. That's easy. 1 times 2 cubed. So that's 8. So that's 8. So there you go. That's equation of tangent line. Use that to approximate 1.1. So you do y minus 2 equals 8 times 1.1 minus 1. So y equals 2 plus 0.8. Or y equals 2.8. That's your approximation. Easy peasy, right? And then determine whether it's greater than or less than 1.1. What you're going to want to do there is look at the second derivative. Now remember, when you're concave up, your tangent line is going to be under approximation, right? When you're concave down, your tangent line is going to be an over approximation. So you're going to plug in 1 and 2 for x and y respectively here. So 8 equals, not 8, equals 8 times 1 plus, you're going to do 3 times 1 squared times 2 squared is 4. So that's obviously going to be positive. So you're concave up, so therefore it's an under approximation. So that's how you would prove it. And just maybe make a statement that, concave up, under approximation. Lastly, when you're defining, when you're doing the separable differential equations, you're going to move the y cubed to the other side. So it's 1 over y cubed dy equals x dx. So you integrate, so that's going to be x squared over 2 plus c. And that's y to negative 3 power. Add 1 to the exponent, you get y to negative 2 divided by negative 2. Yeah, so negative 1/2 y squared. Solve for c, plug in your initial conditions. You put in 2 for y, so you get negative 1/8 equals 1/2. So c is going to be negative 5/8. So you have negative 1 over 2y squared equals x squared over 2 minus 5/8. You have to isolate. Well, you could probably combine this. So it becomes 4x squared over 8. So 4x squared minus 5 over 8. Probably flip over both sides. And put a negative to the other side. So 2y squared divided by 2. And the square root, which I've really run out of space here. Plus or minus square root of negative 4 over 4x squared minus 5. And then you got to test initial conditions again. If you plug 1 in, I get negative 4 over negative 1, which is 4. Root 4 is 2. But it's going to be positive square root, so yeah. But the algebra, just so you know, because that gets kind of wacky. I think it's only worth 1 point. I think if they give you a point for doing separation, a point for doing integrals, a point for using C, solving for C, and then using it. Let's look at the solution key really fast here. Yeah, so we did that part quickly there. Slope was 8, we knew that. Did the approximation, and it was it was under approximation because we were concave up. We separated. Don't know if you have to give the domain necessarily, but 1 point for separate, 1 point for answer, 1 point for constant integration, then 1 point for actually using it. And then, of course, 1 point for solving for y. So, yeah, they don't really get too much values, so don't really worry so much about that. Okay, so let's do one last one. This is a nice table problem. So asking you to approximate the rate t equals 6. Use a trapezoidal sum to evaluate that integral, which is an average value, just so you know. And this represents the approximate interest at a rate modeled by the following formula that not yet been processed. So I'll have you kind of work that one out. Okay. I'm just trying to understand this one here in a sec. Okay. All right. Okay. Just so you know, part D is going to be the EBT style problem. This will be integrals net change. Pretty obvious that they want you to use trapezoidal sum here, and they want you to approximate the rates at t equals 6. Okay. We'll stop the recording. If you're still working, it's totally fine, but just kind of tell you what's going on here. So if you want to approximate the rate at t equals 6, basically you want e prime of 6, which is approximately going to be E7 minus E5 over 7 minus 5. That's all. So 21 minus 13 over 7 minus 5, or 8 over 2, which is 4. And do you give the units? So it's 400 entries, because in hundredths, right? So you say 400 entries per hour. Okay. When you ask you to use the trapezoidal sum, what you're going to do is you're going to look at the first interval. So you can take the width of that, which is 2 minus 0, and multiply to the y value you see there, 0 plus 4, the sum of those y values. Because the reason why you do that is that 0, 0 is right here, and 2, 4 is right here. So you're creating this trapezoid. It's not quite a trapezoid, so let's do another one, like from 2 to 5, 3, 4, 5, and 13, which is way up here. So the trapezoid kind of looks like this, where this segment, which I'll highlight in yellow, is like that right there. So you kind of tilt your head. That's actually going to be the height of a trapezoid. And this is B1 and B2, or the other way around, I don't really care, but those are going to be the y coordinates. So that's where you add the y coordinates, because the area of a trapezoid, in case you forgot, it's 1/2 times B1 plus B2 times height. And your height, again, is the difference in the x coordinates, or the width of the interval, subinterval. And I forgot there's also 1/2 that we need right here. Then you got to repeat this 3 more times. You got to take the width of that subinterval and add to those y coordinates, 4 and 13. And you keep going until you've exhausted all the subintervals. 13 plus 21. And lastly, 8 minus 7, 21 plus 23. And the units will be, and again, they want you to approximate 1/8 times the integral. So this is just the integral. That's all done so far. So we have to also incorporate 1/8 as well. And that's going to represent average value, because 1/8 is 1 over b minus a. So this is going to be the average number of entries that we received. That's all. Just the average number of entries we're receiving. So that's what that represents. Then for C, how much has not yet been processed? We received 2,300 entries by time, because it's a running value. So we received 2,300 entries minus, and then you're going from 8 to 12. So you integrate this from 8 to 12 of t cubed minus 30t squared. And you use a calculator, mind you. Just be much easier. Minus 976 dt. Because they're asking how many have not yet been processed. So you have 2,300 entries that you just received. At t equals 8 hours, you haven't processed any of those 2,300 yet. And then you process some along the way. So you got to take that difference. And then lastly, what is it the most quickly? If that's actually an EVT problem. So we'll take our derivative and find our critical points. And you could just set that equal to 0 and solve for, or graph that and find the x-intercepts. And also you have to test the endpoints too. You have to test 0 and 8. Well, we already know E is 0 is 0. That's not going to be a max. E of 8. Oh, sorry, process most quickly. Darn it, sorry, it's P, not E. Our endpoints are 8 and 12, my bad. So I have to use my calculator and evaluate P of 8 and P of 12. And then I also have to find my critical points here too. I'll just show you the solution key because that's just much easier. Yeah, I see they just did the slope of the secant line for part A. So we're correct there. And then, yeah, just did trapezoidal sum. They got that. Just the average number of hundreds of entries in the box between noon and 8 p.m. So at any given time is what we kind of expect on average. Right, 23 minus, I did 2,300, so it'd be 700, but whatever. Actually, P of T is in terms of hundreds. Oh, it is, okay. So you want to be careful then. Actually, it'd be better to do 23 minus that and then interpret it in terms of hundreds. And then, right, you do have to find the critical points. With the derivative equal to 0 and just graph in the calculator and find the x-intercepts, which are 9.18 and 10.82. And then plug it back into P of T, and you'll find that definitely is being processed most quickly at the right endpoint or at 12. So, okay. we'll go ahead and end there for today. So what I'm gonna do is I'll send you guys something through Albert IO. Let me put it as a reminder for myself, so I don't forget. And then we'll do a mock exam. I'll probably do some stuff with volume as well as some of the other topics, maybe a trapezoidal sum, L'Hopital's rule, Waverly rates, linearization, and probably optimization. Okay. So I'll do that, and then we'll meet again Wednesday. I'll be able to establish this later tonight, and then you have like tomorrow and Wednesday morning, and then we'll talk Wednesday afternoon at 12 o'clock. We'll do it again. Yeah, so that's it for now. Okay, well, enjoy the rest of the Memorial Day, and I will see you guys on Zoom again on Wednesday.
Bye.
Thank you.
Thank you.
Thank
Welcome.
you.